Largest marine oil spill. 11 workers killed. 87 days of oil leak.
On April 20, 2010, in Mexico, an offshore oil rig in the Gulf of Mexico exploded. What followed was one of the worst environmental disasters in history. The video will explain the causes of the Deepwater Horizon explosion, its environmental and sustainability impacts, and how modern digital technologies can improve safety and prevent future disasters. Failure to interpret data. One major cause was the failure to correctly interpret pressure test data. Unusual readings were detected, but they were misunderstood, and drilling continued without action. Blowout preventer failure. The blowout preventer, a critical safety system designed to stop uncontrolled oil flow, failed due to mechanical and hydraulic problems. Poor decision making. Operational decisions were influenced by time and cost pressures, leading to poor risk assessment and weak communication between teams. Safety oversight failure. Safety oversight was inadequate with insufficient regulatory enforcement and weak internal safety management. Critical safety checks were overlooked, and compliance with safety standards was not effectively monitored, allowing high-risk operations to continue without proper intervention. Environment and sustainability impacts. In the Gulf of Mexico, approximately 4.9 barrels of crude oil were released into the ocean, and over 1,100 miles of coastline were contaminated, damaging wetlands and marine habitats. Marine life suffered severe health effects, including increased disease and reproductive failure. Chemical dispersant pushed oil deeper into the ocean, harming deep-sea ecosystem. Fishing and tourism industry were heavily affected, impacting economic and social sustainability and raising concern about food security. IoT and SCADA. Internet of Things sensors and SCADA system can continuously monitor pressure, temperature, and gas levels, sending real-time alerts before conditions become critical. AI and data analytics. Artificial intelligence and predictive analytics can detect early warning signs, forecast equipment failures, and reduce human error in decision making. Predictive maintenance. Predictive maintenance monitors equipment health, allowing early repairs and preventing sudden failures of safety systems like the blowout preventer. Sustainability framework. A sustainability framework that integrates Internet of Things, artificial intelligence, and digital twins can significantly reduce environmental disaster and improve operational safety. Real-time monitoring enables early detection of leaks and abnormal conditions, while predictive maintenance prevents equipment failure before accidents occur. Real risk versus virtual model. Digital twins allow visual monitoring of offshore equipment, predicting failures without putting workers at risk and reducing downtime. This approach supports Sustainable Development Goal 7, which promotes safe, reliable, and sustainable energy. Key lesson learned. The Deepwater Horizon disaster highlights 3 key lessons. Warning signs must never be ignored. Strong safety culture and communication are essential. And technology should support, not replace, responsible human decision. The Deepwater Horizon disaster shows the cost of poor safety system and decision. With the right technology, strong safety culture, and sustainable practice, future can be prevented.